Welcome to the deep dive. Today, we're really getting into the nuts and bolts of IT.
Yeah, we've got these like exam practice questions. They seem simple, but there's a lot underneath.
Exactly. We want to pull them apart, understand the core ideas. Think of it as a faster way to get these key tech concepts without getting totally bogged down.
Right. We're using the questions as springboards, really, to see how everything connects from your phone to, the huge systems running the internet.
And it's quite a range, isn't it? Our source stuff covers contactless payments, cloud computing, even fixing your PC.
A bit of everything.
Okay, let's dive straight into the first one. Which technology allows a smartphone to be used as a contactless payment device? Options: NFC, Bluetooth, Wi-Fi, infrared.
Okay, so the answer there is NFC, near field communication.
Near field, that's the key part, yeah.
Totally. We're talking super short range.
Yeah.
Just a few centimeters. And that closeness, well, that's actually a big part of why it's secure for payments.
Right, so when you tap your phone for Apple Pay or Google Pay, that's NFC doing the work. Quick, easy transactions.
Yep. But what's really interesting, and our source material kind of hints at this with cloud scalability, is what happens after the tap.
Ah, behind the scenes.
Exactly. Think of it, millions of people tapping their phones.
Right.
All at once sometimes. How does the cloud handle all that traffic? Securely. Instantly.
It's huge, yeah. You just tap and go, but there's this massive scalable cloud engine making it all happen reliably.
Make you think, doesn't it?
Definitely. Okay, let's move on. Next question. What is a switch used to determine where to send data on a network? Your options: MAC address, IP address, subnet mask, default gateway.
All right, this one is the AMC address.
Well, the AMC address. Okay, so how is that different from, say, an IP address? Switches are more local, right?
Yeah, exactly. A switch is mostly concerned with the devices plugged right into it on the same local network. Every network card in your computer, your phone, whatever, has this unique hardware ID. That's the AMC address.
So the switch isn't looking out at the whole internet, just its immediate neighbors. How does it use those MAC addresses then?
Well, it learns. It builds this thing called a MAC address table. When data comes in one port, the switch looks at the destination MAC address on that data packet. Then it checks its table. Okay, which port have I seen that MAC address on before? If it knows, it sends the data straight out only that port.
Ah, so it doesn't just shout it out to everyone.
Nope. That's the efficient part. It directs traffic precisely, avoids cluttering up the network.
So if I send something to my printer downstairs, the switch knows exactly which wire, which port the printer is connected to because of that table?
Precisely. Keep your home or office network running smoothly. Now, the source also mentioned Azure Stack HCI deployment considerations.
Right, connecting the dots again.
Yeah, because understanding this basic MAC address stuff, it's actually super important when you're setting up these more complex hybrid cloud things, where your local gear needs to talk seamlessly to the Azure cloud.
Yeah, I can see that. You'd need to know exactly how devices find each other at that fundamental level for it all to work.
Definitely. Get the foundations wrong, and the complex stuff just won't fly.
Okay, good point. Let's move to hardware. Question 3. Which type of expansion slot is commonly used for modern graphics cards? Options: PCI, PCIe by 16, AGP, ISA.
The answer you're looking for is PCIe by 16.
PCIe by 16, right. I know PCIe is Peripheral Component Interconnect Express, but what's the by 16 part mean, and why graphics cards specifically?
So PCIe is the standard high-speed connection slot on a motherboard now. The by 16 tells you how many data lanes it has. 16 lanes is pretty much the widest, fastest connection commonly used for things that need a lot of bandwidth.
Like graphics cards.
Exactly. Think about gaming, right? Or video editing, 3D stuff. Your graphics card, your GPU, is constantly crunching huge amounts of visual data and talking back and forth with the rest of the system, the CPU, the memory.
Okay.
It needs that big, fast PCIe by 16 pipe so it doesn't become a bottleneck, so everything stays smooth.
Got it. So if you're building a gaming rig or a video editing machine, that PCIe by 16 slot is non-negotiable, basically?
Pretty much, yeah. And the related point here is interesting. Solution selection based on business growth.
How does a graphics card slot relate to business growth?
Well, think about future-proofing. If a business relies on, say, design software or simulations, they need powerful graphics, right? Choosing systems with good PCIe by 16 support now means they can easily slot in better GPUs later as their needs grow or a new tech comes out.
Ah, so they aren't limited by the connection itself when they want to upgrade.
Exactly. Skimp on that fundamental interface, and you might box yourself in down the road, unable to take advantage of faster hardware. That can definitely hinder growth.
Makes sense. Plan ahead with the basics. Okay, next up, cloud models. Question 4. Which cloud model provides users with access to software applications over the internet? Your options: IaaS, SaaS, PaaS, private cloud.
That'd be SaaS, software as a service.
SaaS.
Okay.
And this is probably the one people use most, even if they don't call it that, right?
Absolutely. It's everywhere. The key thing with SaaS is you're just using the software. It runs over the internet, usually in a browser.
So I don't install it, I don't update it, I don't manage the servers it runs on.
Nope. The provider handles all of that. You just log in and use it.
Like Gmail or Google Docs.
Perfect examples.
Yeah.
Or Dropbox for file storage, Microsoft 365 Online. Those are all SaaS. Super convenient.
Definitely. And the source connects this to storage architecture in Azure Stack HCI. How does that fit?
Well, all those SaaS apps you're using,
Yeah.
they need to store your data somewhere, right? Your emails, your documents, your files.
Mm-hmm.
That data lives on complex, robust storage systems in the cloud. The kind of storage architecture that things like Azure Stack HCI are built around. So while you see the app, underneath there's this whole storage infrastructure making it work.
Right, the hidden engine again. Okay, question 5, troubleshooting time. A technician hears clicking noises from a user's desktop hard drive and the system won't boot. What's the most likely cause? Options: failed hard drive, overheated CPU, corrupted OS, loose RAM.
Ooh, the click of death. That's almost certainly a failed hard drive.
The clicking is the giveaway?
It really is. That clicking sound usually means there's a physical mechanical problem inside the drive. Maybe the read-write heads are hitting something or the motor's failing.
And if that's happening, it can't read the data.
Exactly. It can't access the operating system files needed to boot up. Game over for that drive, usually. The other things: overheating, OS corruption, RAM. They cause problems, sure, but that specific clicking noise points very strongly to the hard drive itself.
A critical failure.
Yep. And the related point mentioned is HPE ProLiant servers with Azure Stack HCI. This really underscores why reliable storage is so critical in servers. Imagine that clicking sound coming from a server holding vital business data.
Yeah, nightmare scenario. Highlights the need for good hardware, backups, and redundancy.
All of that,
Right.
especially in those complex hybrid environments.
Okay, let's shift gears slightly. Question 6. Which of the following allows you to connect a smartphone to a projector wirelessly? Options are USB-C, Bluetooth Miracast, NFC.
The one you want there is Miracast.
Miracast, I've seen that setting. What is it exactly? How does it work?
It's basically a standard for wireless screen mirroring. It lets your phone or tablet or laptop beam whatever's on its screen directly to a compatible projector or TV, wirelessly.
Like AirPlay on Apple stuff, but more universal.
Kinda, yeah. It often uses Wi-Fi Direct, which means the phone and the projector talk directly to each other. They don't even need to be on the same Wi-Fi network.
Oh, handy. So just connect the two devices.
Pretty much. Great for presentations, sharing photos, whatever, without messing with cables.
Definitely convenient. And the source links this to high availability in Azure Stack HCI. How does wireless display relate to high availability?
It was maybe a bit of a stretch, but think about setting up for, say, a presentation. Fewer cables mean fewer potential points of failure, right?
Mm-hmm.
Easier setup, maybe more flexibility in where you present. It contributes in a small way to making the whole presentation setup more available and reliable.
Interesting angle. Reducing complexity to increase reliability. Okay, networking again. Question 7. Which device separates broadcast domains in a network? Options: hub, router, switch, access point.
The device that does this job is the router.
A router. Okay, we talked about switches keeping traffic local using MC addresses. What's a broadcast domain, and why do routers separate them?
Right, so a broadcast domain is like a neighborhood on your network. If one device sends a broadcast message like shouting, "Is anyone named Bob here?"
Yeah.
Everyone in that domain, that neighborhood, hears it.
Okay.
Switches operate within a broadcast domain. But routers, they connect different networks, different domains together. And crucially, they act like gatekeepers. They don't let those broadcast shouts from one neighborhood spill over into all the others.
Ah, so they stop the noise from spreading everywhere.
Exactly. Imagine if every broadcast on the entire internet reached every device. Total chaos.
Nah.
Routers keep broadcasts contained, which makes the network way more efficient, less congested, and actually more secure too.
That makes a lot of sense. Keep the local chatter local. And the connection here is administration tools for Azure Stack HCI.
Yeah, think about managing a big, complex environment, how you set up your routers, how you segment your network into these different domains directly impacts how you can administer it, apply security policies, troubleshoot specific areas without affecting others. Network segmentation is key for manageability.
Got it. Boundaries are important. All right, question 8, back to hardware connectors. Which connector type is commonly used for internal hard drives in modern desktops? Options: IDE, USB, SATA, Thunderbolt.
For internal drives, hard drives, or SSDs in modern PCs, the standard is SATA, serial ADA.
SATA. What did that replace? I remember older drives had those really wide gray ribbon cables.
That was IDE, or sometimes called PATA. Parallel ADA. SATA was a huge improvement. Much faster data speeds, for one.
Right.
And the cables. SATA uses thin, simple cables, much easier to plug in, much better for airflow inside the case compared to those bulky IDE ribbons.
Definitely an improvement. And the related point is public cloud use cases. How does SATA connect to the cloud?
It's more of an analogy, I think. Just like SATA replaced IDE in our desktops for better speed and efficiency, the storage technologies inside those massive public cloud data centers have also evolved dramatically. They're constantly moving to faster, denser, more efficient ways to store and access data on a huge scale. Same principle, different context.
Evolution towards speed and efficiency, whether it's your PC or a giant data center. Cool. Okay, question 9 is about running multiple operating systems. A technician is running multiple OSs simultaneously on one physical machine. What's this called? Options: dual booting, virtualization, emulation, clustering.
That's called virtualization.
Virtualization, not dual booting, right? Dual booting is when you choose one OS or the other when you start up.
Exactly. With dual booting, only one OS runs at a time. Virtualization lets you run multiple operating systems at the same time, concurrently, on the same physical hardware.
How does that even work? Is it like tricking the OSs?
Sort of. You use special software called a hypervisor. The hypervisor sits between the hardware and the operating systems. It creates these self-contained compartments called virtual machines, or VMs.
Okay.
Each VM gets its own virtual set of hardware resources: CPU, RAM, storage, and you can install a whole separate OS inside each VM. So you could have Windows running in one VM, Linux in another, all in the same laptop.
Wow, why would you do that? What's the benefit?
Oh, loads of benefits. Testing software on different OSs without needing separate computers. Developers use all the time. Running older applications, consolidating multiple servers onto one piece of hardware to save power and space. It's incredibly flexible.
I see. And the connection is to characteristics of infrastructure as a service, IS.
Yes, because virtualization is basically the foundation of IS cloud services. When you rent a virtual server from AWS or Azure, you're getting a VM running on their massive infrastructure managed by their hypervisors. IS is essentially offering virtualization on demand at scale.
Ah, okay. So the VMs we might run on our own PC are the same core idea as the servers we rent in the cloud. Makes sense. Last question, number 10. A user's display appears distorted and pixelated. Which component is most likely failing? Options: RAM, hard drive, video card, power supply.
With visual problems like distortion and pixelation, the prime suspect is usually the video card, the GPU.
Why the video card specifically? What's it doing that would cause that?
Well, the video card's entire job is to take data from the CPU and turn it into the picture you see on your monitor. If the card itself is failing, maybe overheating, maybe components are dying, it can't process that data correctly. That leads to visual errors, artifacts, weird lines, messed up colors, pixelation, the whole screen looking garbled. Could also be a driver issue sometimes, but physical distortion often points to the hardware itself.
So graphical weirdness usually equals GPU problems. And the final related point: HPE infrastructure services for Azure Stack HCI.
Right. It just brings it back to the idea that reliable hardware is critical everywhere, whether it's your desktop GPU or the complex infrastructure running a hybrid cloud solution like Azure Stack HCI, which might even use powerful GPUs for certain tasks. You need that underlying hardware, including graphics processing in some scenarios, to be solid and dependable for consistent performance.
Absolutely. Can't build complex systems on shaky foundations. So here's a final thought to leave you with. We've seen how connected things like networking, hardware, and cloud services are. Thinking about that interconnectedness, what kind of cool, maybe unexpected innovations might emerge in the future where these different IT fields blend together even more?
That's a good one. Definitely something to chew on. The lines are always blurring.
Indeed they are. Keep exploring.